This is a Kirchoff problem, and you know you have to apply Kirchoff's rules when you see more than one battery in the circuit. So in this circuit there would be 3 different currents, one in the upper branch, one in the middle branch, and one in the lower branch. In order to apply Kirchoff's rules, the junction rule says that currents in must equal currents out. Goes out. Okay, so I'm going to choose this point, I'm going to call it point D, and I'm going to call this point C, and this corner B, A, F, and E. At junction D, I'm going to have current I3 entering, I'm going to have current I1 leaving, and I'm going to have current I2 entering. So my junction rule will be I3 plus I2 is equal to I1. I'm going to call that equation number 1. Now, once I've decided on the currents, I'm going to put a current vector beside each resistor in the direction the current is flowing. So I1 flows left to right, right to left through the 4 ohm resistor, which means this is the positive side and this is the negative side of that resistor. I3 flows left to right through the 2 ohm resistor, so that would be the positive side, that would be the negative side, and I2 also flows left to right, so that would be the positive and that would be the negative. Putting the positive and negatives on the resistors helps you when you're doing your voltage summations around any closed loop. So now we apply the loop rule, which says that the sum of all voltages around any closed loop must be 0. So I'm going to choose loop A, B, C, D, A. So that's the upper loop, and I'm going to go clockwise around that loop. So as I move from A to B, there's no change in voltage. I cross the 12-volt battery from plus to minus, so I end up on the negative side, so that's downhill, so it's negative 12. I'm going against current I1, so I'm going up a hill, so that's plus 4I1. Turn the corner, come around, and now I'm going against I3, so it would be plus 2I3 would equal 0. I'll call that equation number 2. Now I need one more equation because I have 3 unknown currents. So now I'm going to do loop F, A, D, E, F. So I'm going to go clockwise around the bottom loop. So I first pass along in the direction of I3, so that's negative 2I3. I'm going downhill there. Now I'm against I2, so I have plus 6I2. And I end up on the negative side of the 8-volt battery, so it's negative 8 is equal to 0. And I'll call that equation number 3. Now those are 3 equations and 3 unknowns. But because equation 1 is so simple, I'm going to reduce the system to a 2x2 system by subbing in number 1 into number 2. And so when I do that, I get negative 12 plus 4, and instead of I1, I'm going to put I3 plus I2. I still have a 2I3 is 0. Tidying that up a little bit, I'm going to have 4I2 plus 6I3 equals 12. I'm going to call that one number 4. And then I'm just going to rewrite number 3 so it looks a little better. I have 6I2 minus 2I3 is equal to 8. And I'll call, that's just number 3 again. Alright, now I'm going to apply Kramer's rules to this 2x2 system. And to use Kramer's rule, I have to make a master matrix, which is the determinant of the coefficients of the unknowns. So it's 4, 6, 6, negative 2. Calculating the determinant of that, I get negative 8 minus 36 is negative 44. Now to calculate the unknown I2, I replace the first column of that master matrix with the right-hand column of my equation set. So instead of 4 and 6, I'm going to write 12 and 8. Leave the second column alone. Divide by the master determinant. And we get negative 24 minus 48 over minus 44, and that I2 would be 1.6 amperes. Now with I3, I replace the second column, leave the first column alone, the 4 and the 6. Second column I replace with the 12 and the 8. Still divide by the determinant of the master, and I get 32 minus 72 over minus 44, and I3 turns out to be 0.9 amperes. And I know that I1 is equal to I2 plus I3, so that's equal to 2.5 amperes. And that is using Kramer's rule to solve a Kirchoff circuit.